In this video, I want to discuss an application of centripetal forces. Specifically, I want to talk about how the space station stays in the air, or how the moon stays in the air and doesn't crash into the Earth. Now, sometimes people think that the reason that the moon and the space station don't crash to the Earth is because maybe if you get high enough, gravity is somehow turned off, right? But we know from the law of gravitation that there is gravity. Even though it's weaker, there's still a force of gravity from the Earth at the space station and pulling on the moon towards the Earth. All right, so why in the world don't they crash? So when I first learned this 20 plus years ago, I thought this was fascinating and it blew me away. So let me try to explain it to you now, how satellites work. All right, so we know that centripetal forces make things move in a circle, and gravity is going to be the centripetal force that keeps the moon and the space station in an orbit around the Earth. Okay, what happens is they have a velocity, tangential velocity, tangent to the circle always that they're going in, and again, the gravity pulls it towards the Earth, and so that's what keeps them going in a centripetal. That's what keeps them moving in a circle. All right. Now, Newton explained this by something called Newton's cannonball. So, suppose we had a cannon, powerful cannon at the North Pole. Okay? If we fired it with an ungodly amount of gunpowder, then the cannon would approximately come out straight. It would slightly bend towards the Earth because of gravity, but not too much. Okay? Now, if you gave it a little bit less gunpowder, maybe it's going to still escape, but it's going to bend a little more because it's a little slower. So maybe it would go something like this. All right? Now, what if you didn't give it enough to escape the Earth? Well, then the cannonball would come out of the cannon and it would bend down and crash into the Earth somewhere. If you gave it a little more, it would maybe go a little farther, but it would still bend and crash into the Earth somewhere farther away from the cannon, right? So if you have too little gunpowder, it crashes to the Earth. If you have a lot more gunpowder, it escapes the Earth. Okay, so one situation it crashes to the Earth, and then the other situation it escapes. Now, right in between those two cases, if you're right on the fence at a certain value, you're neither going to crash to the Earth nor are you going to escape. Okay? At a certain value, what's going to happen is you are going to be trying to crash into the Earth, but because the Earth keeps bending underneath you, you never actually crash. So you're continually falling towards the Earth. Isn't that cool? That just blew me away when I first learned that. So to explain, the space station and the moon, as well as all the other satellites orbiting the Earth, they are continually falling at high speed towards the Earth. However, because the Earth is curved and because the direction of gravity keeps changing, it's centripetal, okay, that makes it, at the end of the day, that they keep falling in this circle forever and ever. All right? Isn't that cool? I just love that. So that's the explanation of how satellites stay in the air, and it's all based in space, and it's all based on centripetal forces.